In this video, I'm going to be writing a simple task manager application in Golang using the BubbleT framework and also using the libgloss and bubbles libraries. Let's get to it. Okay, we are starting in our simple Go project. We have BubbleT imported and also we have defined a main function. So let's create our model structure, which won't have any fields for now. Then let's create the update function, which takes in a t message and returns a t model and a t command. So for now, we are going to just return the model and nil as the command. So we will switch on the message type to handle the message. And in case it's a key message, we will switch on the message string. And if it's Q or Control-C, we will return the model and a t.quit command, which just exits our application. Okay, let's create a init function, which returns a t command. We will return nil because we don't want to do anything at the startup. Okay, now let's create the view function, which just returns a string, which BubbleT will then render. So for now, we just return hello from BubbleT. Let's also create a function that returns a new model, which is going to be useful later. And now let's actually start our application. So we create a new T program, then we start the program, and if there is an error, we exit. And program start is deprecated, so we have to use program.run. But it also returns the final state of the model, but we don't need that. So, and when we run our app, we can see the message, and when we press Q, we exit. Okay, so let's try adding a counter to our model to show some of the features of BubbleT, and then in the view function, we just define a new string, and to that string, we just add the text that displays the counter, and we return the string. And we can see the value of counter, which we set to 0 in the new model function, is displayed. So let's handle some key presses to modify the counter. If the user presses up, we increment the counter, and if the user presses down, we decrease the counter. And when we run our program, we can see that we can control the counter by pressing the arrow keys. So that's everything for this quick example. Okay, so let's actually implement some of the code for the project. First, we have to create a structure that is gonna represent our task. Task will have a title field, a description field, and a status field. So for the status, we will create a custom data type. So status will be an enum of type integer. So we just create a to-do value, a doing value, and a done value. And we will use the iota operator to make this a bit easier. And we want task to implement list.item from bubble T. And a task must have three functions or methods. The first one is filter value, which just returns the value we will sort the tasks by in the list. The second one is title, which displays the title of the task. And the third one is description, which just returns description of the task. So for filter value, we just filter by the title, so we return the title. For title, we again just return the title, and for description, we just return the description. Now that we have done the task structure, we can move on to an already finished implementation of the whole program. So here we are inside of the finished implementation, and we can see the model structure. It has an array of list.models, which are basically the three lists of tasks. It has a focused field, which basically just means which of the three lists is currently focused. If the program is ready, if we are inputting a new task, then it has the two text inputs for the task inputting, one for the title and the second one for the description. It keeps track of the input that's currently focused, and it keeps track of the width and the height of the terminal window. Okay, so let's take a look at how we render the model. So if we are ready and not inputting, we just render the three lists and then join them and return them as a string. And then if we are inputting, we just render the two inputs, join them vertically, add some padding, and return the string. Then let's take a look at the update function. So we take a look if we are inputting or not, because if we are inputting, we want to send all of the messages to the inputs, not the currently focused list. So if we are not inputting, we do the same thing as in the example. We switch on the message type. And in case of a T window size message, we initialize the lists if we are not ready, and the inputs with the proper width and height. And we also update the styles and the width and the height of the current model. Then we register some keybinds. So we register keybinds for moving the cursor around the lists. Then we register keybinds for moving a task around the lists. And then we also register a keybind for deleting the selected task and for adding a new task. And if we are inputting, we again switch on the message type. If it's a window size message, we again update the width and the height. If it's a key message, we switch on the message string. We can use tab to switch between the two text inputs, escape to cancel the inputting, and Control-C to exit the program and save the model, which I'm going to talk about later. And we use Enter to finish inputting a new task. Okay, now let's talk about how we save the state of the application so that if we exit it and load it back up, the tasks persist. We do that by converting the model to a JSON file and saving that file to disk. And then, if we want to load the model from the file, we just try to read the tasks.json file. And if we read it, we just convert the JSON back into a structure. If we can't read the file, that means that there was either an error or the file does not exist. So we just return a clean model. And if we manage to load the file, we just convert it into a model structure, which we return. And now let's take a look at how the app looks and functions. So when I launch the app, there are already some tasks from previous tests. I can use X to delete the current tasks, and I can use A to input a new task. And we can see the task. So now, if we exit the app and launch it again, we can see that the task is still there. That's it for this video. I really enjoyed writing Go code, and the code is available on GitHub. The link is in the description of the video.